Okay guys, this is for question number 2. So question number 2, again same thing, number 2a Roman 1, they ask you to find dy dx. So remember again, dy dx is the gradient function, so we want to find the gradient function. So 2 you go in front, so 2x and then power minus 1. Here we only got x, so since we got x we can just ignore, will directly give you negative 4. So that's Roman 1. And then in Roman 2 they were asking about coordinates of the turning point. Okay, so some of you might forgot what is turning point actually. Okay, I'll just explain very briefly here, okay, for those of you has forgotten. Okay, so we have a lot of curve, along the way we'll see lot type of curve. Okay, so assuming I'm drawing this curve. Okay, I draw this curve. Yeah. Okay, so if you see this is a S, okay, there usually we call turning point at this kind of spots. Okay, why do we call this as a turning point? Okay, this has two names. One is known as turning, okay, turning point, and they also can share the other name which is known as stationary point. Okay, both of them serve for the same purpose. Of course you'll be wondering why they have turning point and stationary point. I'll explain now. Okay, so turning point is why they call this turning point, because you see I'll explain in two terms, one in terms of maths, one in the layman terms. Okay, it's up to you, as long as you understand, that's fine. So in maths way, what we say, if you see here, this gradient is from a positive, it's going and going and going and going. At this point here the gradient will become 0. So once comes 0, after this what happened, the gradient is going to go down and down and down, and it will eventually reach to negative. Same to here, from negative it's come and come and come. At this point here the gradient will reach 0, and then we change to become positive. So the transition of the gradient from positive to negative, that's the point where we call turning point or stationary point. So in layman terms, let's say we do want to understand through the maths sophisticated way, in simple English means this curve is building up. Can you see it's building up, and then at here something cut off and he had to go down. So at the point where the curve build and get cut off, that's where we call turning point. It's like it turned everything. Supposedly the curve should go up, right? But what happened at this turning point, the curve was forced to go down, so we call this turning point. Same thing here, when it comes here it's supposed to go down, but at this point it decided to go up, so we call this also turning point. So usually why they use this word turning point and stationary point, reason because whenever you see these two keywords, turning point or stationary point, you must let dy dx equals to 0 for you to find the turning point. Okay, so the same thing we're going to do here. Since Roman 2 they asked to find the coordinates of the turning point, so I will assume dy dx equals 0 because they say turning point. If they didn't mention turning point, stationary point, you cannot do that. Okay, so 2x minus 4 equals to 0. So you do your math here and you will get your x is 2. But bear in your mind they ask for coordinates, so you cannot stop at x, you have to proceed all the way to y. So I'm going to find a y. How do I find my y? I can actually take this x2, replace inside here and find my y, right? So I'm going to do that here. So 2 square minus 4, 2 and plus 1. So 2 square is 4. Here you got about 8 and you got plus 1. So negative 4 plus 1, negative 3. So where's my coordinate? Here. So there you go, you got a package of the coordinates. Okay, alright, and then let's see what's the next question talking about. Okay, the next question is asking you state with a reason whether the turning point is a maximum or minimum. Okay, so this one we want to explain whether the turning point is a maximum or minimum. So what we can do usually in maths, okay, those who took at maths, you will know to determine whether maximum minimum you can do double differential. But bear in your mind this is mathematics, you cannot do that. Don't argue saying that I can do faster way. No, okay, that's at maths. In maths we have another way to prove whether this turning point is a maximum minimum. So I will take this function and write down to show you how in maths we will show. Okay, so dy over dx equals to 2x minus 4. So we have obtained our x earlier as, where is it? Our x we obtained as 2. Okay, so now assuming my x is 2, so to determine whether a function in maths, remember you must show this step in maths. So you want to know whether it's a max, okay, max or min. Okay, you have to do this step. Okay, you can take either, up to you, however you can take, but you must take one lesser value, one upper value. So usually we have the habit, we take 1.9 and then 2 and then 2.1. We want to see the difference what happened. So I'll take 1.9 and I'll sub inside the function. Okay, so I take 1.9, I sub inside, so I will write here dy over dx. Okay, so 2 1.9 minus 4. Okay, so let me get my calculator and I press. Okay, so 2 bracket 1.9 minus 4, I will get negative 0.2. Okay, so I get negative 0.2. Then I will repeat again. Okay, for the this figure. Okay, again I tell you, if you ask me why I specifically take point, it's my choice. You also can, instead of taking 1.9 and 2, you can take 1 and 3 also, no problem. Okay, just don't take too big lah. Later you want to press in calculator, it will give you a problem here. Okay, so we are almost the tail end here already, and you get here positive 0.2. You notice? Okay, initially it was before it's negative 0.2, after is 0.2. So basically what they're trying to tell you now, previously, okay, this gradient was leading to you see 0.2, let's say 0.2 must be here, 1.9 somewhere here. So the curve is leading to negative. Once it reach here, it changed to positive already. You can notice or not, see the difference. Gradient, the gradient was telling negative. So at 1.9 the gradient was leading to negative. After pass 2, when it reached 2.1, it positive already. So this kind of curve we call as a minimum. Okay, so since they ask you state a reason whether the turning point is a maximum or minimum, so you can this is actually your reason. This is what you're supposed to show as a reason. Okay, you show this working, they'll understand, and then you say yes, it is minimum. Okay, so guys, I know for advanced student you will feel that this is unnecessary, but I'm sorry, you have to do this. Okay, so in the end they ask you find the equation of line of symmetry for the curve. Okay, so line of symmetry. Okay, I think, I mean, all of the students last time took admaths with me, you will know lah. Okay, so line of symmetry, actually we're talking about when we cut the curve, the left and the right should be the same. So the trick is, okay, you see you look power 2 and it's a positive. Okay, so I'll just do a bit recap here. So a is more than 0. So a more than 0 means what, guys? It's a minimum function. Remember, okay, a little bit you will do this completing the square last time, but you cannot do here now. So you know it's a minimum. Okay, so what we do, we can sketch this graph, just a rough sketch. So it should be a minimum graph. So in a minimum graph, you know this point here should be your line of symmetry, because when I cut here, my left and the right of the graph is the same shape. So what point is this, guys? Remember I taught you earlier, okay, where this curve change the transition is called as your turning point. So basically your turning point, where is it? This turning point is your answer for question C, which is x equals to the line of symmetry. Understand? Okay, I repeat again, line of symmetry means when you imagine you put a mirror, okay, you want to see the reflection left and right. So at this point here, when at this point here you put your mirror, the left and the right will be the same. So this point earlier I have taught you is known as the turning point. Okay, so that's question number 2. Thank you.